Encapsula Nanosciences presents liposome size, the relation between liposome size, lipid concentration, and the number of unilamellar liposome particles in the solution. The concepts presented in this animation will explain how to calculate a unilamellar liposome's size, lipid concentration, and number of particles. A unilamellar liposome consists of only one lipid bilayer. The ideas presented in this video will not work for larger multilamellar liposomes. In order to calculate the number of lipid molecules in a unilamellar liposome, we must first calculate the area of the outer surface layer of the liposome. R stands for the radius of the liposomes. Geometrically, the area of the outer surface of the sphere is calculated using the equation 4 pi r squared, where r equals the radius and pi equals 3.14. Next, we must calculate the area of the inner surface layer of the liposome. H equals the height or thickness of the phospholipid bilayer. The area of the inner surface layer of the liposome is calculated using the equation 4 pi multiplied by radius minus height squared. Finally, to calculate the total surface area of a unilamellar liposome, we use the equation 4 pi multiplied by radius squared plus radius minus height squared. A is equal to the lipid head group area. In order to calculate the total number of lipid molecules in a unilamellar liposome, we divide the total surface area by the lipid head group area. For example, in phosphatidylcholine, we can calculate the total number of lipid molecules to be approximately 80,047, when the head group area is 0.71 nanometers squared, the height of the phospholipid bilayer is 5 nanometers, and the radius is 50 nanometers. To calculate the particle concentration of liposomes per milliliter, we use the equation molar concentration of the total lipid multiplied by Avogadro's number divided by the total number of lipids per liposome particle multiplied by 1,000. For example, in a 100 nanometer unilamellar liposome with a lipid concentration of 3 micromolars, there is about 22.6 billion liposomes per milliliter. Finally, to calculate the volume of a unilamellar liposome, we use the equation 4/3 pi radius cubed. When the radius is doubled, the equation becomes 4/3 pi 2 multiplied by the radius cubed. The total volume of the sphere increases 8 times. In theory, this means that 8 times the amount of drug is encapsulated inside the liposome. Further information about liposomes may be found at our website, www.encapsula.com. Requests for liposome formulations customized to your specifications and pricing information may be sent to info@encapsula.com. This animation may be used by researchers, professors, lecturers, students, etc. for educational purposes only. No part of this animation may be used for commercial purposes, including development or proposed development of a product.